What if the strange, silent travelers hurtling through our solar system are more than just cosmic debris? What if they are not rocks, but tools? Imagine for a moment these interstellar wanderers, our uninvited guests, are clues. Clues that hint at an astonishing, almost unthinkable possibility. They might be evidence that our entire universe, everything we see and everything we are, is not what it seems. That it is a grand, elaborate simulation. A construct so vast and so perfect, we never had reason to question its authenticity. Until now. These objects with bizarre trajectories and unexplained properties could be the first signs our reality is managed from the outside. Think about it. We send probes to Mars, we send probes to Jupiter. We send rovers to explore distant landscapes. We are driven by curiosity to understand worlds beyond. Maybe another intelligence is doing the same to us. Or something stranger is afoot. They might not be for exploration. They might be for maintenance, like a mechanic tuning an engine, like a programmer patching software. These could be cosmic instruments of repair, sent to fix a glitch in the fabric of existence. They fly by, silent, perhaps tweaking a fundamental constant or adjusting a law of physics. That idea forces us to reconsider our place. We look up at stars, galaxies, nebulae. We assume a natural, unguided universe from the Big Bang under immutable laws. But what if those laws are not immutable? What if they are lines of code? And what if that program sometimes develops bugs that need correcting? The arrival of objects like Oumuamua defied classification. It behaved like no comet or asteroid we had seen. The idea that our universe is a simulation sounds like science fiction. But it has deep roots in philosophy and modern physics. Think about the world of software development. A programmer creates a virtual world, complete with its own rules, physics, inhabitants. In a video game, characters move, interact, live their lives, all governed by the underlying code. They are completely unaware that their reality is a product of a programmer's design. They cannot perceive the hardware running their world or the intelligence that created it. From their perspective, their world is the only one that exists. Now ask yourself, how do we know we are not in the same situation? This concept is known as the simulation theory. It proposes that our universe, with all its galaxies, stars, planets, is an artificial reality. It is a simulation created by a far more advanced civilization. Just as we create increasingly complex simulations on our computers, modeling weather patterns, creating sprawling virtual worlds in video games. A few decades ago, our most advanced video games were simple pixels on a screen like Pong Space Invaders. Today, we have photorealistic virtual reality environments that can trick our senses. We can simulate the formation of galaxies and the folding of proteins. If we project this rate of technological advancement forward, thousands or even millions of years into the future, what might be possible? It seems plausible that a civilization that advanced could create simulations indistinguishable from reality itself. Our universe could simply be one of many such simulations running on a cosmic supercomputer. The analogy to software management is a powerful one. Programmers do not just create their software and walk away, they monitor it, they maintain it. They look for bugs, inefficiencies and errors in the code that could cause the program to crash. When they find a problem, they release a patch and update to fix it. If our universe is a simulation, it stands to reason that its creators, the grand programmers, would do the same. In 2017, our solar system received its first confirmed interstellar visitor. We named it Oumuamua, a Hawaiian word meaning scout from a distant past. But this was no ordinary space rock. It was bizarre. First, there was its shape. Based on how its brightness flickered as it tumbled, astronomers deduced it was extremely elongated, perhaps 10 times longer than it was wide, like a cosmic cigar or needle. We have never seen an asteroid or comet with such an extreme shape in our own solar system. It was an immediate red flag. This object was different. It came from somewhere else, and it did not play by the rules we were used to. Then came its motion. As Oumuamua swung around the sun, it accelerated away faster than gravity alone could explain. Comets do this all the time. As they warm up, ice turns to gas and jets out, acting like a tiny rocket engine. This is called outgassing. But here's the mystery. Astronomers looked for any sign of a coma, the fuzzy cloud of gas and dust that surrounds an active comet, and found nothing. There was no visible evidence of outgassing, yet it was accelerating anyway. This non-gravitational acceleration was a profound puzzle. What was pushing it? Was it made of some exotic material we couldn't see, like solid hydrogen, or was it something else entirely, something artificial? Just 2 years later, in 2019, a second interstellar object was spotted, Oumuamua and Borisov. This one behaved more like a conventional comet. It had a visible coma and a tail, and its composition seemed familiar. But its appearance so soon after Oumuamua was itself significant. It suggested that interstellar objects might be more common than we previously thought. For centuries, we believed our solar system was an isolated island. Now, we know it is a crossroads. Objects from other star systems are regularly passing through our neighborhood. We just needed telescopes powerful enough to spot them. But Oumuamua remains the true enigma, the one that makes us question our assumptions. So let's put on our simulation theory hats. If Oumuamua was not a natural object, what could it be? Its strange acceleration without a visible tail makes it look suspiciously like a probe under controlled power. Avi Loeb, a Harvard astronomer, famously suggested it could be an artifact of an alien civilization, a solar sail, or a reconnaissance craft. But what if its purpose was not exploration, but maintenance? What if it was a diagnostic tool sent by the simulators? Its trajectory, its speed, and its strange behavior could have been precisely calculated to analyze a specific region of our solar system, perhaps to investigate a potential bug or instability in the code of reality that was emerging here. Let's dive deeper into this wild idea that these interstellar objects are not just probes but bug fixes for the universe. How would that even work? The analogy to software updates is, surprisingly, pretty fitting. When your computer or smartphone needs an update, it downloads a small package of code. This patch is designed to find specific files or lines of code in the operating system and overwrite them with new, improved versions. It might fix a security vulnerability, improve performance, add a new feature. The process is targeted and precise. The patch doesn't rewrite the entire system, just the parts that need changing. Now imagine this process on a cosmic scale. Imagine our universe is running on a set of fundamental physical laws: gravity, electromagnetism, strong nuclear force, weak nuclear force. If a bug were to emerge, say a slight drift in the fine structure constant in one corner of a galaxy, it could have disastrous consequences over cosmic timescales. The simulators would need to intervene. They couldn't just halt the entire universe to fix it. That would be like shutting down the entire internet to fix one website. Instead, they might deploy a physical object, a patch, programmed to travel to the affected region of spacetime. This object, like Oumuamua, would be designed for a specific task. It wouldn't need to be a massive, clunky machine. In a universe where matter and energy are interchangeable, E equals mach squared, and where quantum mechanics governs reality's fabric, such a device could be incredibly subtle. It might release a specific sequence of particles or a focused burst of energy as it passes through the target area. This release could interact with the local quantum foam or the fabric of space-time itself, effectively overwriting the buggy code with the correct version. Its unexplained acceleration could be a byproduct or a sign of an advanced propulsion system. This theory could explain Oumuamua's strangeness. Why no outgassing? Because it wasn't a comet. Its acceleration wasn't from melting ice, but a deliberate, controlled mechanism. Why the weird shape? Perhaps that elongated form was most efficient for interstellar travel, or for performing its specific function. This brings us to a final, profound and somewhat terrifying thought. We have explored the idea that interstellar objects are patches sent to fix bugs in the cosmic code. But what if the bug isn't a glitch in a physical law or a wayward star? What if the bug is a form of consciousness? What if the bug is us? Think about it. A good simulation is one where the inhabitants are unaware they are in a simulation. They go about their lives following the rules of their universe, generating the data the simulators desire, generating the entertainment the simulators desire. But what happens when one of those inhabitants starts to figure it out? Humanity is a curious species. We are relentlessly driven to understand our reality. We have split the atom, peered back to the dawn of time, and are now actively searching for the fundamental code of the universe at places like the Large Hadron Collider. We are writing papers about the simulation hypothesis. We are building telescopes to look for strange interstellar objects. We are, in essence, poking at the walls of our prison, testing the boundaries of our reality. From the perspective of the simulators, this kind of behavior might be highly undesirable. A character in a video game is not supposed to become aware of the player. If it does, it has become a bug. If we are identified as a bug, what would the fix look like? It might not be a dramatic Hollywood-style shutdown. The simulators could deploy a subtle patch. It could come in the form of an interstellar object that sails silently through our solar system, releasing a targeted program designed to subtly alter our development. Perhaps it could tweak our planetary environment to make further technological progress more difficult. Or maybe it could introduce a new idea into our culture, introduce a new belief system into our culture that steers us away from these dangerous lines of inquiry. And so we must ask, if we are living in a universe that is being debugged, what happens on the day we become the bug?